ladies. What we're going to do today is talk about graphing linear equations. So right now you want to make sure that you have your notes ready, that you have your handouts, ruler, pencil, etc. You can go ahead and title your notes 8.3 representing linear functions, and we will go ahead and figure out how we can graph lines using tables and intercepts. And we will also look at special lines, including horizontal and vertical lines. So let's get started. Okay. Don't copy this graph down. I just wanted to show you in general what I'm looking for. So here you want to make sure that you always label your x and your y axes. Make sure your axes have arrows on either end to show that the axes do go on forever. Your line as well should also have arrows, unless we're talking about a real life situation where the arrows don't make sense, to show that this line goes on forever. And make sure you do label your x and y axes with number scales. The numbers go below the x-axis and they go to the left of the y-axis. Also, just as a side note, this is something you do want to write down. Your axes do not have to have the same scale. So for example, you could count by ones on your x-axis and count by 100s on your y-axis. Think of population graphs. You might want to be counting by the thousands or even millions with population graphs, but you would not do that on the x-axis because maybe you're looking at years and you want to go from 2000 to 2001, 2002, 2002. So just make sure that you remember that you can count by different units on your individual axes. But for the most part, we can keep them the same: ones, twos, fives, and tens. Okay, let's go ahead and take a look at our first linear equation, y equals negative 2x. To create a table of values, we can start with our xy table. And what we want to do is find solutions to this equation. What pairs of numbers make this equation true? That's the idea. So what could we put in for x, and what would we get out for y, input, output? It doesn't matter where you start. I usually like to start with a couple of negative numbers for x, and then 0, and then maybe a couple of positive numbers. But you can start wherever you'd like. And again, we are choosing values for x. And then we solve for y. We can do a lot of these in our head. If I substitute a negative 1 in for x, what's negative 2 times negative 1? Well, that's positive 2. So the ordered pair negative 1, negative 1, positive 2 is a solution to this equation, because when you substitute these numbers in for x and y, you get a true statement. Does 2 equal negative 2 times negative 1? Yes. That's true. Okay. And we can do this again and again and again. Let's go ahead and substitute 0 in for x. Negative 2 times 0 is 0, so that is another ordered pair that makes this equation true. If I substitute 1 in for x, I get negative 2. If I substitute 2 in for x, I get 2 times negative 2, which is negative 4, and so on and so forth. We could do this forever, but that would be a waste of our time. The textbook, I think, typically asks for about, 4 solutions. So here I have 4 solutions. Your 4, again, may be different from the person sitting next to you, because maybe they chose the numbers 3, 5, 7, and 9 to start with in the x column. It doesn't matter, because as you will soon see, when we graph all of our different ordered pairs, they will line up, because this is a linear equation, a linear line. So on your graph paper right now, go ahead, please, and graph this equation, graph these ordered pairs. So again, with your graph, make sure that you have arrows on either ends of your axes and that your axes are labeled x and y. I can't notate on the screen, otherwise I would do that, but here you should have an x, here you should have a y. And when you go ahead and graph your points, I've just graphed a couple here, but all 4 of your points should line up. So 0, 0, here's 1, negative 2. I can graph another point. We have negative 1, comma 2. And when you do go ahead and draw your straight line, make sure you are using your ruler, your straight edge. Please do that. connect my points here. You should get a line that looks like this. And this line represents all of the solutions to y equals negative 2x. Because again, we didn't even have to choose integers. I could have chosen negative half and substituted that into my equation and gotten 1. And you can see that that point also lies on this line. So that's why we connect all of our points, because I want to show every solution, not just the 4 that I happen to come up with. Let's take a look at another equation. Let's say we have x plus y equals negative 5. Okay, let's go ahead and come up with some ordered pairs that make this equation true. Again, there are lots of different ways to do it. You can probably just look at this equation and come up with some ordered pairs in your head that work. So what two numbers add together to get negative 5? Well, we know that negative 2 plus negative 3 happens to equal negative 5. So there we go. I've put that in. Also, negative 3 plus negative 2 happens to equal negative 5, the reverse. But let's say you weren't able to do that off the top of your head. Let's just use the method that we were using before, and let's substitute a number in for x. So let's say we have 0, because again, 0 usually works pretty nicely, and maybe I have to do a little bit of work here on the side just to make sure I know what y is going to equal. I substitute 0 in for x. 0 plus y equals 5. Here we go. By our property, we know that 0 plus y equals y equals 5. Done and done. So 0, 5 is another ordered pair that makes this, oops, I forgot something here, very important, my negative sign. Negatives are really important, so as I've said before, make sure you highlight them, make sure they stand out. And I was just double checking up here and went, oops, forgot my negative. So 0 plus negative 5 equals negative 5. And let's go ahead and substitute one more value in. Let's say I put in the number 1. Okay, what would that look like? 1 plus y equals negative 5. To solve for y, I'd have to subtract 1 from each side. And just be careful with your calculations. Remember, this is negative 5 minus 1, which is the same as negative 5 plus negative 1. So we're getting more and more negative. We're going to get negative 6, and that will be the value we substitute in for y, okay, with this x equaling 1. So again, if you need to do some math on the side, do it. Show your work, reason your way through the mathematics to make sure that your calculations are accurate. Now let's go ahead and graph this line. So grab your graph paper and start drawing this line. You can even pause the video to draw your line and then just check it with mine. Okay, so here's what your graph should look like. Again, please have arrows on either end of your line and on your axes. But I've graphed the different points and I've connected them, again showing all of the different solutions to the equation x plus y equals negative 5. Okay, let's go ahead and do some practice. Using the handout you were given, page 19, please complete number 11. Hit pause and then unpause it when you're ready to see the solution. Okay, this is what your graph should look like. Take a good look at it. If your graph does not look like this, it might be because you got confused by that negative sign in front of the x. Remember, you can always write in a 1, so you can have a negative 1x, the negative 1 being your coefficient, and that can help you when you are substituting in negative and positive numbers for x to help you reason through the negatives. So let me just show you for a moment what my table looked like. So here are my values. I have negative 1, 4, 0, 3, 1, 2, 2, 1. And as you can see, I rewrote the equation so that there's a negative 1 coefficient in there, which can help me with the calculations. Let's go ahead and talk horizontal and vertical lines. They are special. So I'll start over here. Horizontal lines, they are functions because they pass the vertical line test. Okay. And they're always in the format y equals some number. So for example, we might have y equals 4. If I were to make a table for this, you might get stuck because what do you put in for x? I don't see an x here. There aren't any calculations. Turns out you can put in anything you want for x because I don't have any parameters as to what x should be, so it could be anything. Negative 1, 0, 1. But I do know that y has to equal 4, independent of what x happens to be. Let's go ahead and take a look at what this graphed line will look like. So when I graph my points, 0, 4, -1, 4, 1, 4, you can see that you do in fact get a horizontal line. Let's take a look at vertical lines. So let's just go back to our notes for a moment. Remember, vertical lines go up and down. Vertical lines, think about it, are they functions? Well, if I were to graph a line, a vertical line, on top of this vertical line, it turns out that it would intersect in every point. So vertical lines are not functions. They are still lines, however, okay, because a vertical line is, in fact, a line. So we would consider it linear. Vertical lines are of the form x equals some number. So I might have, for example, x equals 6. Let me go ahead and just move my notes over to the next page. Same idea as before, except the variables are obviously switched. Instead of just choosing whatever I want for x, I am told that x equals 6. 6, 6, 6, 6. I could do this forever. Okay, but what about y? Well, I'm not told anything about y, so I can put in anything I would like for y. Maybe I'll have -1, 0, 8, 10, 1,000, or 5, whatever you'd like. And when we go ahead and graph these points, you will see how they line up vertically. So let's go ahead and take a look at that graph. So here we go. We have x equals 6. I have 6, 0, 6, 1, 6, 2, 6, 3, 6, 4, etc. And they all line up. So just in summary, you can make tables for horizontal and vertical lines if you're not sure what they look like, or you can just know that with horizontal lines, you have y equals some number, and for vertical lines you have x equaling some number. So if you ever see equations of these forms, you can go, oh, this is horizontal. It's horizontal where y happens to equal that number, and you can draw that horizontal line. Same thing with the vertical. Oh, x equals 5. Okay, well, wherever x equals 5, I'm going to put a point, and that will give me my vertical line. Let's go ahead and take a look at intercepts, because intercepts are a really cool way to graph lines as well. And which intercepts are we talking about? X-intercepts and Y-intercepts. So what is an intercept? Well, think of an interception in football. It's where another player grabs the football out of its intended mark, out of its intended line. And that interception, when we're talking about the coordinate plane, forgive my lines, remember this tablet does not afford me very straight lines. It's where your graphed line happens to cross the x and y axes. So my x-intercept and my y-intercept. If I know those 2 points, I can graph the line, because you only need 2 points to graph a line. Why have we been making tables with 4 or more points? Well, that's just to make sure our calculations are good and that all of our points actually line up. We want to have as accurate graphs as possible. So the more points we have to graph, the straighter our lines will look on paper. But if I gave you an equation that looked like this, 2x plus 3y equals 12, it might be a little tedious to create a table of values, though you could do it. You would substitute in for x and solve for y. You may get fractional or decimal values, and those might be a little bit tricky to graph. So instead, when you're given an equation like this, we might solve for just the x and y intercepts. Well, how do you do it? Well, to find the x-intercept, okay, we want to substitute a value in for y and solve for x. Now, why are we going to do this? Well, think about the x-intercept. Everywhere on the x-axis, the point is going to look like some number x, comma, 0. It's 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, and so on and so forth. So if I know that y always equals 0 in my x-intercept, I'm going to substitute 0 in for y and solve for x. It's really cool and really quick with this type of equation. Because what happens when we put in a 0 for y? Well, that drops out. 3 times 0 is 0. Then you have 2 times some number equals 12. You can do that in your head. X equals 6. Now we need to write it as an ordered pair. It's 6 comma 0 because remember we put in a 0 for y. And if I know 6, 0, I now have 1 point on this line. So let's go ahead and take a look at the y-intercept. Okay, so what's so special about the y-intercept? Well, it's very similar to the x-intercept. On the y-axis, okay, all of our points here are 0, comma, some number. So it's 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on and so forth. So I'm going to substitute 0 in for x and solve for y. So let's go ahead and do that. I'm going to substitute a 0 in for x. That drops out. 3 times what number equals 12? That's 4. So again, when I have put in a 0 for x, I get 4 for y, and that's my y-intercept. Let's go ahead and graph these 2 points and see what our line happens to look like. Okay, so as you can see here, when I graph the intercepts 6, 0, and 0, 4, and then draw the line between them, I have the line for the equation that I was given. What I would like you to do now is to go ahead and go to my Moodle page and click on the online quiz 483, answer those 3 questions, and I will see you in class tomorrow. We're going to explore these topics a lot more. Okay, thank you.